Welcome back to Solving Problems Together. Today we're going to dive straight in to a problem involving a compound shape made of two triangles. We've been asked to find the length x. So just like we always do for problem solving, let's start by thinking which maths might be useful in this problem. Firstly, because I have right-angled triangles, there are two things I think of immediately: Pythagoras and trigonometry. One or both of these might be useful. I also noticed that the two triangles have an angle of 60 degrees and a right angle, which means that these two are similar shapes, similar triangles. That could be useful. And finally, since we're trying to find an unknown, I'm sure I'm going to use forming and solving equations. Okay, let's get started. Although the problem gave these two triangles conjoined in a compound shape, I'm going to split them up and work with them individually. So, the large triangle has a vertical height of x, and the smaller triangle has a vertical height of 6. As long as I can find some corresponding lengths, I can set up a ratio which should help me to solve for x. So let's find some more of these lengths. The two triangles share this length. It's the hypotenuse on the small triangle, and it's the adjacent length on the larger triangle. If I can find that, that gives me a bit more information for each triangle. I can also find this yellow length, which will give me a corresponding side between the two triangles, and the other corresponding side would be the vertical unknown x value. So, if I can find these three lengths, I should be able to use similar triangles to find this unknown length. I'll start by labeling these to help with the algebra and the equations that I'm going to set up, and I'm looking to find h first. So, focusing on the smaller triangle, I know that h is the hypotenuse. I also know the opposite, and I know the angle. I can use sine theta equals opposite over hypotenuse. If I substitute in, sine 60 equals 6 over h. Sine 60 is root 3 over 2. Rearrange to solve for h equals 12 over root 3. In a similar way, I should be able to find a length for y, but I won't be using sine theta since this time round I'm working with the adjacent and the opposite. Tan theta equals opposite over adjacent. Let's substitute what we know. Tan 60 equals 6 over y. Tan 60 is just root 3. If we make y the subject from here, y equals 6 over root 3. h is 12 over root 3, y is 6 over root 3. And there is something I notice about these two values. One of them is twice the size of the other. Is this going to be useful later on? So now I know the values of h and y, I'm just going to substitute those in. And now we can focus on the similar shapes. We can focus on the similar triangles. Because the lengths of similar shapes, the lengths of similar triangles are proportional, a fraction constructed of corresponding lengths would match for both of these triangles. I'm going to do the vertical over the horizontal. So x divided by 12 over root 3 equals and must be exactly equal to 6 divided by 6 over root 3. As I said before, these two surd terms have a direct link. 12 over root 3 is twice the size of 6 over root 3. I'm going to rewrite the second fraction by doubling the top and doubling the bottom, multiplying by 2 in the numerator and 2 in the denominator. Now that these two have a common denominator, I can see quite easily that x must equal 12. X equals 12. So looking back, I didn't actually use any Pythagoras. I went for the trigonometry option, and I could have done a combination of both. We used the similar shapes to set up this fraction equation, and then we used our algebra skills to solve for x. What were your initial thoughts on how you might solve the problem? I know already that there are multiple different ways this problem could have been solved. If you have any interesting techniques or alternate ways to solve, do share that with us in the comments below. And if you can pose a way to take this problem further, to make it more challenging, we'll definitely want to hear about that as well. Thank you for joining us, and we'll see you again soon to solve another problem together.